Cloud Computing Explained. Part 4. How does traffic find your app? Think about a normal business day. A customer opens your online store, a colleague checks a dashboard, and a supplier sends a file. Different moments, but the same hidden requirement. Every request must find the right service and get there safely. Compute can be ready, and the data can be stored. However, without a network, neither one is reachable. In plain English, cloud networking connects the pieces. So, before choosing a networking service, let's start with 4 practical questions. Who is connecting? What are they trying to reach? Should that destination be public or private? And what happens if demand rises or something fails? Those answers create the map. Everything else helps the cloud enforce it. First, your cloud resources need a place to connect. A virtual cloud network, often called a VPC, creates a private boundary for one environment. Inside it, subnets separate different jobs. The public entrance can stay apart from the application and data behind it. Still, the boundary only organizes the space. Access must be granted deliberately. Next, the request needs directions. People use names, such as your company website. DNS translates that name into a network destination. Then, routes choose the next step, while gateways provide a controlled way between networks. So, an address says where, a route says how, and a gateway provides the way through. However, one entrance should not depend on one machine. A load balancer receives each request and sends it to healthy application capacity. When traffic rises, more instances can share the work, and when one fails, it can be removed from the path. To the customer, there is still one front door. Behind it, the service can grow and recover. Of course, a route only says that a path exists. Security rules decide whether the conversation is allowed. For example, customers may reach the web entrance. The application may reach an internal service, and only that service may reach the data it needs. Everything else can stay closed. The goal is simple: allow the intended connection and nothing more. Now, let's follow one business through the map. The customer reaches the public entrance, and the load balancer sends the request to a healthy application. The application follows a private route to storage. Meanwhile, employees use a controlled company path, and a supplier reaches only the partner service. One business, several paths. Each one exists for a specific reason. So, when someone asks how the cloud should connect, return to the questions. Who needs access? What are they reaching? Which path should traffic follow? And what must remain private? Then add resilience, so the service still has a healthy destination when demand changes or a component fails. Good networking is not the most complicated diagram. It is a clear set of intentional paths. Of course, reaching the application is only the next step. The application still needs to organize, update, and retrieve information. In the next episode, we will look at databases and why different kinds of data need different kinds of memory. If this made cloud a little clearer, subscribe and follow the series. I'll see you in the next episode.